Hello friends, welcome to our channel Crash Course for the Engineers. In today's session, we'll talk about heat transfer and mostly related to the heat conduction. Uh, let's go to the uh, history which is related to the heat transfer. Now, friends, you'll be surprised to know that in the 19th century, uh, the people used to think that the heat is an invisible fluid called as a caloric that flows from a hot body. Suppose there is this hot body, I'll show it by edge, and there is another body which is a cold body. So suppose there is another body which is called is shown by cold body. So the heat transfer between these two uh, is assumed to be by an invisible fluid known as a caloric. So this is the caloric. Okay, and because of this, what used to happen that the hot body gets cooler and the cold body gets warmer. Now, as the time uh, flows, uh, there was new theories related to heat transfer, and uh, one more thing was stated that kinetic theory. Okay, so in case of this kinetic theory, the assumption was uh, they were saying that the molecules act like small balls which are in motion and they possess the kinetic energy. And because of that, there was the term which was associated heat. The heat was called as the energy associated with the motion of atoms and molecules. Okay, uh, we know that heat is a form of energy uh, that can be transferred from one system to another system because of the temperature difference. As I given you an example, uh, in this example, there are two bodies. One is a hot body and another is a cold body. Now, friends, when we are saying it's a hot body and cold body, we are saying that it means that there is a temperature difference between these two bodies. Okay, there is a difference between this thermodynamics, no, dynamics and heat heat transfer. Now, what is the difference? The difference is very important because we want to study heat transfer. So, thermodynamic analysis is concerned with the amount of heat transfer the system undergoes from one equilibrium state to another. So, in case of thermodynamics, we deal with the amount of heat which is transferred. Now, when we talk about heat transfer, we want to find out or we want to determine the rate of energy transfer. So, that's the term comes into picture, which is called as the heat transfer. If we want to have the heat transfer between two bodies, we should have the temperature difference. If there is no temperature difference, there will be no heat transfer. If the two bodies are at same temperature, there will be no heat transfer. There are three modes, basic modes of heat transfer. First is conduction, heat transfer by conduction. Second is heat transfer by convection. And third is heat transfer by radiation. And as we know that uh, for all these three modes of heat transfer to happen, there should be the temperature difference. Now let's discuss about heat conduction. So what is heat conduction? It is the transfer of heat energy from a more energetic particle of a substance to the adjacent less energetic ones as a result of interaction between the particles, between the particles. So the definition tells us about the transfer of energy from more energetic particles. Now this word is very important in the definition to adjacent adjacent less energetic particle. Okay, so adjacent less energetic particle. Okay, so if the energy is more, the temperature is more. If the energy is less, the temperature is less. Now, if we want to find out how the heat conduction takes place in uh, different phases, that is, if I want to find out how the conduction takes place in the solids, suppose this is the solid body, and in case of the solid body, we know that solid has a lattice structure. So solids are having this kind of structure. The structure is pure orderly, having pure order. Okay, and also in some of the solids you will find that there is a presence of electrons. Electrons are present, free electrons are present. Okay. Now, in case of solids, the conduction takes place because of the vibration of lattice. Sorry, vibration of lattice, and also because of free electrons. So, if I have hot end here and on this side, what will happen? The molecules on this side will get more energetic. Because of that, there will be vibrations, and that vibration will pass on the towards the right hand side. And at the same time, the molecules to the left side will get more energetic. Because of that, the electrons will acquire energy, and the electrons will leave their position, and it will go towards the less energetic side. And this way, the heat conduction in case of the solids will be because of the vibration of lattices and the free electrons. Next, we have liquids, the intermolecular. Uh, if we talk about the liquids, the intermolecular distance is more. So, if we talk about if these are the molecules, okay, so these are the molecules. So, what will happen? The intermolecular distance is less. Okay, so I am showing two kinds of molecules which have lesser energy and molecules shown by red color are the molecules which have more energy. Hot. Okay, so in case of the liquids, the intermolecular distance is more as compared to the solids. So in case of liquids, the heat conduction will take place because of the molecular collision. So this more energetic molecule, red color, will collide on the less energetic molecules and the heat transfer by conduction will take place. And also because of the molecular molecular diffusion. So as the molecules spread into the volume of the liquid, the conduction will take place. Now, friends, understand that the quantity of heat conducted in case of solids will be more as compared to the liquids because the quantity which is transferred by collision and diffusion will be comparatively lesser as compared to the solids. Now, talking about, let's talk about gases. Gases will have the same kind of thing, but the distance between the molecules will be more. The intermolecular distance is more as compared to the liquids. So, as I am showing, the intermolecular distance is more. So, what will happen? The molecular collision and molecular diffusion is responsible for heat conduction in case of gases, but there may be chances that the molecules don't collide to the less energetic molecule. Till they travel to the next molecule, the energy will be lost and the conduction will not happen. So the quantity of heat conducted in case of gases will be lesser than the uh, liquids. So friends, I can say that you conducted, conducted in solids will be more as compared to the liquids and it will be than the gases. So solids conduct more heat, liquids lesser, and gases will be comparatively lesser. Now, the rate of heat conducted, as I am talking about, can be found out. That is, Q conducted can be found out by the Fourier's Fourier's law of heat conduction or heat heat conduction. So now, suppose there is this there is this wall, and suppose we have that the wall inner side temperature is T1, outer side temperature is T2. Suppose this area is A and the thickness of the wall is del X. Okay, now the condition we can say that this area inside is equal to area outside I am talking about. So there will be heat conduction takes place from the inner area to the outer area, and this is the direction x, positive x direction. Okay, so what Fourier's law of heat conduction tells us, the rate of heat conduction, the rate of heat conduction is proportional to the area. Now this area should be perpendicular to the direction of heat flow into temperature temperature difference divided by the thickness. Okay, so uh, for our diagram, we can show it like this: is proportional to the area. The temperature difference can be written as T2 minus T1, that is outside temperature minus inside temperature, divided by the thickness del X. If we want to remove the proportionality sign, so equal to, I need to add a constant Ka. Now this T2 is lesser than T1. So what we'll do, we'll add a negative sign and it will make T1 minus T2. Sorry, just 1 minute. It should. Okay, so T2 minus T1 upon del X. So pure conduction. Now there is a negative sign in this equation. I have added this negative sign later. This negative sign is very important because uh, if we don't add negative sign, I'll get the heat conduction in positive x direction. So heat conduction in positive x direction, the value should be positive. Okay, so that's why the negative sign is added so that we get the heat conduction in positive x direction as positive. Or uh, other ways, I can write it as Ka T1 minus T2, that is higher temperature minus lower temperature into del X. So this is the equation for heat transfer by the conduction. Now friends, understand that this K, which is which we added, uh, this is called as the K as the thermal conductivity. Thermal conductivity. Now this K, it can be defined as the measure of the ability of the material to conduct heat. So it is measure of ability of material to conduct heat. So more the value of K, the material will conduct more heat. We can find out the unit of this K. Uh, so let us find out unit of K. We know that heat conduction is in watts. K unit we need to find out. Area is in meter square. The temperature difference can be written in Kelvin or degree Celsius, and thickness of the material is in uh, meter. So K is equal to watt meter upon meter square Kelvin. 1 meter will get cancelled out, so watt per meter Kelvin. Or as in this numerator, if you look, there is a subtraction of temperature. So T1 minus T2. So I can write it in the form of watt per meter degree, watt per meter Celsius, degree Celsius. Okay, both the things will be same because it's a temperature difference. Understand, friends? Uh, I cannot write in terms of watt per meter Fahrenheit. So this will be wrong. The difference value will be different in case of Fahrenheit. So this is not possible. So it will be mistake. Only I can write in terms of Celsius or uh, Kelvin. Now, as I told you, this thermal conductivity is the ability of material to conduct heat. The more the value of heat conductivity, the more will be the heat transfer. Let us take an example. Suppose I have a wall and suppose this inside temperature is 30 degrees Celsius, outside temperature is 20 degrees Celsius. Okay, 30 degrees Celsius and 20 degrees Celsius. Now this suppose this wall is of 1 meter length. In one case, suppose this I use the material of copper and the conductivity of copper is 400. And in another case, I use the material as silicon and the conductivity of silicon is 148. Suppose. Now, what will happen, friends? The heat conducted in case of copper will not be equal to heat conducted in case of the silicon. So, conducted in case of copper will be 4000 something, right? So, 4000. Now, in case of uh, silicon, the heat conducted, let me calculate the value. 1 meter, the heat conducted will be equal to 1480. Simple calculation is there. So uh, it means that the heat conducted depends on the heat conductivity, and heat conductivity is the property of the material. More the heat conductivity, more heat will be conducted by the material. Now understand, friends, let us go to the next thing, very important thing. The materials are uh, divided into good conductors of heat, good conductors of heat, and insulators. Thus, depending on the value of conductivity, that is K. Let us take an example. Uh, the materials which are like, for example, Ag, silver, then copper, gold have good value of thermal conductivity. Then I can say aluminium, then iron have good conductivity. So these materials are called as the uh, good conductors of heat. Then your brick, various types of bricks, then air, then rubber are the material examples. Then urethane foam, rigid foam. foam are the insulators of the heat. Uh, Now, because of this, depending on the application, we use the materials so that wherever we want heat conduction more, we will be using above materials, and in case of insulators, we'll be using these materials. Now, friends, understand that this this thermal conductivity of the material material is very important property if we want to study theory related to heat transfer. That's all for today's session. If you have any query related to the content, please put it in the chat box. Your comments, your subscription to the channel motivates me to post more and good content related to the uh, theory and the numericals in mechanical and civil engineering. Thank you, friends, for watching the video.